Hello developers, today we are going to build an artificial intelligence based virtual agent. By the end of this video, you will have a working assistant that you can customize and use in your own project. End users today expect seamless 24/7 support. Virtual assistants provide an easy to use natural language interface. For any businesses, providing such a seamless, always available support is a priority. Today you will build an AI virtual agent using NLP. Let's get started. We'll be using a Kandi kit to build this AI solution. Now what is a Kandi kit? Kandi one-click install kits gives you ready-to-deploy solution with complete source code. You can access many more such ready-to-use Kandi kits on augmented reality, artificial intelligence, blockchain, gaming and many more on Kandi. Today we'll be using a popular Kandi kit which is AI Virtual Agent one-click install kit. Now this kit is open source and comes with a permissive license. That means you can freely edit, customize and share your own solution. So let's get started then. Over to you Pooja for a hands-on walkthrough.
Hello, hope you are excited to build your own virtual agent. To be able to build it, you would need the following: a dataset comprising of frequently asked questions. Second, an NLP pipeline to pre-process these questions using the linguistics and text hero library. Third, a sentence transformer that will help you convert this text into machine understandable form. Fourth, a cosine similarity that will help you compute the similarity between user query and stored embeddings. Everything that you need is already available in the Kandi kit. So over the next few minutes, we will cover three key aspects in this video. First, download and installation of the kit. Second, a simple coding exercise on filtering tokens using Spacie. Third, demonstration of the working solution. Let's start by installing the kit. Check the description for the link to the installable. This will set up a working sandbox application with all the needed prerequisites and resources. You can download the installer here and also check the deployment information below. So we will download a zip onto our local system folder. We will extract this zip file. Double-click the folder. Double-click this batch file to start setting up the kit. Say more info, run anyway. So this will start setting up all the needed requirements automatically onto your systems. Once your kit gets successfully installed, you will see this message. Just say yes and a Jupyter notebook will automatically open for you. Before we go ahead and discuss the details of the solution, let me help you with an interesting coding exercise on how to remove tokens using Spacie. So for that, I'll open a new notebook. Go back to my virtual agent page. Click on this kandi.openbeaver.com. So this helps you search for interesting functions, code snippets, libraries, etc. and ease up and jumpstart your application development. We will make the search as filter tokens. In a document, and as we make the search, we'll click on the code snippets. We'll go ahead and see that we have many such results available. I'll choose the first one and copy it and paste it on this notebook. And now I would see that if there are any changes that I would like to do in the code for correctness. So for loading the model, I'll have to quickly make a change here. So this is the purpose from which we will be able to extract, or I would say remove your punctuations, numbers and symbols if there are any in the text. So this is the document that is being worked upon. As you paste this code and change this model here, also add these two instructions for downloading the English and the English Core WebSM model. Once added these, then we'll run the solution. And here we see that this is the statement that we had added onto as a document here. We want to just remove tokens. So punctuations, numbers, and symbols would be removed. So let me add an @ here, some numbers here, and these punctuations, and then rerun this to showcase you the change in the result. Currently, we have this as the output without any punctuation symbols or numbers. So let's rerun this. Only an example I would like to create again. So they've removed the number, they have removed the punctuations. So yeah, this is good to go. Let's deep dive into the Jupyter Notebook. So first of all, we have provided with our FAQAS, which is our frequently asked question data set, into the CSV format. Then we are storing it via pickle into a file. We have imported all the necessary libraries here. And then we have loaded our data set into a data frame format, which you can see here has a couple of records which talk about what is Kandi and different questions about the Kandi kit. You can have any other data set as well. What we are doing further is we are removing any unnecessary text, any punctuation, stop words. We are basically removing any digits which are not necessary and which are not required by the machine. So on our question column, or this is our query question column, we will apply .pipe remove digits and remove punctuations. And after removing everything, we will store it into a processed queue column, which is this, which no longer has any digits or any question mark symbols or any stop words. After that, we have loaded our sentence transformer for converting this processed text into machine understandable embeddings form. We are storing these embeddings using pickle.dump into a file. Up till here, we are finished with our training part of our model. Then now we need to test our model. So for testing, we have again loaded these stored embeddings. And within this spread_answer, what we are trying to do is on our test query or the user query, which we are fetching from here, we are processing it and putting it into our data frame format, then removing the digits and punctuations as well from this query and storing it into another column called clean user query, and then applying the cosine similarity to compare the clean user embedding with the stored embeddings. So whichever embedding is closest to the user embedding, that would be fetched, and against that fetched user fetched embedding, we will be able to get the answer to this query based on a lookup that will happen for the meshed query from the data frame. So we can see for the query where we have asked about tell me about Kandi, we are able to get Kandi is a platform that helps, this is the response that we have been provided by our model. So this is a simulating virtual agent that we have created for you so that you can test this model for yourself. And let's just run it. So now we can test our model here by asking some quick questions. What is the use of Kandi? So it will tell that, it can be used to collect some code samples, API, cloud functions, pick write libraries, etc. And maybe we can ask another question like, how can or maybe what are the functions provided by Kandi. So it will give me the same answer that it has some 430 million. Let me change some question and ask what functions I can perform using the Kandi kits. So for this, it has given me that, it has given me this answer where two options are present. One is for search, another is for explore, right? So we can use this model since we now have our own working model. You can play with it, understand it, explore it, and even customize it. I hope you are set now, and congratulations. We are done finishing this interesting use case for you.
Hope you found this session useful. Using a Kandi kit is a great way to build AI predictive engines. You can find the link to the AI Virtual Agent Kit and many other ready to deploy kits in the description. Head over to Kandi to build incredible projects on augmented reality, artificial intelligence, blockchain, and many more. Try out Kandi kits now. Hit that subscribe button and join us at the OpenWeaver community of developers to learn more and build many more incredible projects. Thank you for watching this session. Till the next one. Bye-bye.